So we're practicing for the AP test. This is one of the practice free response questions. We've done a couple problems like similar to this. Okay, so I'm going to go through each one. So starting with part A. Okay, so it says we have a continuous function f. It's defined on this interval from -5 to +8. The graph of it, f, which consists of 4 line segments, is shown in the figure above. So this is my graph of f. Let g be a function given by this equation here. So g of x is equal to 2x plus the integral from -2 to x of f of t dt. Okay? So it's asking us to find g at 0 and g at -5. Okay? Well, that means we're using the equation they gave us, g of x. Okay? So for the first part, we're finding g at 0, which means basically wherever we see x, we're going to plug in 0. So this is going to be 2 times 0 plus the integral from -2 to 0 of f of t dt. Okay? So for the first part, 2 times 0, that's 0, plus this integral right here. Basically, remember, the integral is nothing more than area. So this is saying that we need to find the area from -2 to 0 under my function f. So we come up to here and we say, okay, here's -2, here's 0. We're finding this area right here. Well, really easily we can split it up into geometric figures. We have a rectangle of area 2 and a triangle with area 1, just using 1/2 base times height. So that means that area is 3. So our answer is 3. That's it. Okay? So this problem is just conceptual. Okay? So, the next part. It says find g at -5. So same thing. So 2 times -5. Start plugging in -5 wherever we see x, plus the integral from -2 to -5 f of t dt. And that's going to be equal to -10. Now, this area right here, notice that my limits are backwards. So we're going to switch the limits to make it from -5 to -2, which changes the sign on my integration. So -5 to -2 f of t dt. And then we come back up here, and in this second part, I'm going to erase this, we're finding the area from -5 to -2. So we're finding this area and that area. And so this triangle here, height of -4, width of 2, so this is -4. And this one has a height of 2, width of 1, so this is 1. Now remember, since this area is underneath the x-axis, this is negative. So -4 plus 1 is -3. So this is equal to -10 minus -3, which ends up being -10 plus 3, which is -7. And that's it. That's part A. Okay? So the hardest part about this one is just knowing that the integral that they give you, this right here, we're using this to define g by finding the area underneath my function f. Okay? Now, part B. It says find g of x in terms of f of x, and for each g prime at 4 and g double prime at 4 and g double prime at -2, find the value or state that it does not exist. So, let's start with the first part. Find g prime of x. Well, we know this is g of x. So we take the derivative. So the derivative of 2x is 2. And then we're going to take the derivative of this. So plus d over dx, the integral from -2 to x of f of t dt. This is the fundamental theorem of calculus. If you're taking the derivative of an integral, the top matches my derivative, the bottom is a constant. That means I take my function, and wherever I see t, I'm going to plug in x. So that means that g prime of x is 2 plus f of x. Okay, so there's my g prime. That's the first part in terms of f. That satisfies this. But now we have to find g prime, g double prime. So g double prime of x. So we take the derivative again. So derivative of 2 is 0, and the derivative of f is f prime of x. So the second derivative of g is the first derivative of f, which basically means that g prime at 4 is the slope of my function. So g double prime at 4 is the derivative at 4. And we all know that the derivative is nothing more than slope. So 1, 2, 3, 4. So we're looking for the slope at this point right here. So m, so rise over run, or y2 minus y1 over x2 minus x1. Since the slope is not changing, we can use that. So that means we get negative 3 minus 3 over 2 minus 8, which ends up being negative 6 over 6. Oh, I did this wrong. This is 3, positive 3. So it would be positive 6 over negative 6, which is negative 1. So this is negative 1. Just like that. And then the other part, find g prime at negative 2, which is f prime at negative 2. So again, we go back up here, and this is right here at negative 2, so what is the derivative there? Well, remember the derivative is slope. Also, where is a function differentiable? A function only has a derivative where it is smooth and continuous. Well, is that smooth? No. So there, the derivative fails to exist. So here, the derivative does not exist. And that's it. And again, so basically the math here is not very difficult. We're talking about rise over run, and the derivative is pretty easy as well. The problem is the conceptual part. Do you understand the concept that they're asking you to do? All right, part C. On what intervals, if any, is the graph of g concave down? Give a reason for your answer. So I keep telling my students they need to have this chart memorized, the one that relates f, f prime, and f double prime. So when my function is increasing, my derivative is positive. When my function is decreasing, my function is negative. Where I have a min or a max, my derivative is 0. Now, where my derivative is increasing, my second derivative is positive. Where this is decreasing, this is negative. And whether this has a min or a max, my second derivative has a 0. But that also means that here, the function's concave up when my derivative is increasing, and it's concave down when my derivative is decreasing, and I have a point of inflection when I have a min or a max in my derivative. So if I'm asking for where is my function concave down, that means I'm looking where my derivative is decreasing. So again, since this right here, we've already established that g prime of x, right, is f of x. So this right here, since we did this already, we know that the derivative of g is this function. So wherever this function is decreasing, where f is decreasing, that means g of x is concave down. So where is this function decreasing? It's decreasing on the interval from negative 2 to 0, right here, and from 2 to 8. That's where it's decreasing. And that's what you're going to write. g of x is decreasing on the intervals -2 to 0 and 2 to 8 because g prime of x is decreasing. Oh, sorry. This is decreasing, this is concave down. Is concave down on the intervals from -2. So basically all you're doing is you're telling them, justifying your reason for your answer is just you telling them how did you know. And this is how we know right here, because since the derivative is decreasing, my function is concave down. And that's what I said. G of x is concave down on these intervals because g prime is decreasing. Okay? Now, you could have said where the second derivative is negative, but we don't know anything about the second derivative. They haven't told us any of that. So we have to use the information that they've given us. Okay? And that's part C. And then the last part, it says the function h is given by this equation. Find h prime at 1. Show the work that leads to your answer. Okay? So the first thing we need to do before we can find h prime at 1, we need to find h prime. So when I take the derivative here, I'm taking the derivative of this. This is literally a function inside of this function. So we have x cubed plus 1 inside of g, which means if I'm taking the derivative with a function inside of a function, I have to do chain rule, or the inside-outside rule. So the derivative of the inside is 3x squared times the derivative of the outside is g prime of x cubed plus 1. So there is the derivative. That is h prime. Okay? Now, we're going to find h prime at 1. So we plug in 1. So it's 3 times 1 squared times g prime of 1 plus 1, which equals 3 times g prime at 2. Now we have to use g prime at 2, and we use what we had earlier. So this is going to be 3 times 2 plus f at 2. Because g prime is 2 plus f of x. So we plug in 2 to our f of x, we come up here. F at 2 is 3, we use that coordinate right there. So h prime at 1 is 3 times 2 plus 3, which equals 15. So, and these aren't hard. Okay, the problems themselves, mathematically, this isn't hard. What makes it complicated is you need to know the concepts. So this concept, the main idea of part D, is absolutely chain rule. Okay, part C, this is, the main idea here is how the derivative relates to my function. This chart right here. So if you don't know this chart and know how it's referencing it in this problem, you can't do this problem. Even in part B, the main idea for this one is just, do you know the derivative is slope? That's all this one's about, is that you know that the derivative is slope and finding a really simple derivative. And then part A is, do you know that the integral is area? Do you know that this part right here is the area under that curve? So these problems aren't mathematically difficult, but they are conceptually taxing.